Can you? Mm. All right. Can you all see this one? This thing. Okay. Can you all see this? Okay. So we'll just do a quick revision on acid, base, and salts, and then also back to our own chapter on organic chemistry. Okay. All right. So when you look at this, okay, this is a strong base. This is not as strong as this. Can you see that? Okay, this is of course neutral, but this too is the one you need to know. This is a weak acid, and this is a strong acid. So you need to know the definition of strong acid and weak acid. A strong acid is an acid that is completely ionized in water, so there's a high concentration of hydrogen ions. A weak acid, partially ionized in water only. Okay? All right. If they ask you to define the term acid, acid is a proton acceptor. But if they ask you to define the term base, sorry, acid is a proton donator and or donor, and base, why is it like this? And base is a proton acceptor. Okay. So definition is according to the syllabus. Definition, you cannot put what you feel is the correct one. Okay, it's according to the syllabus. Can I understand? Okay. 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 Alkali, soluble base. Okay. So a base that is soluble in water is an alkali. A base that is not soluble is just a base lah. Okay. Can. So for example, copper oxide is a base, but it doesn't dissolve in water. So it's just a base. Sodium hydroxide is a base. It dissolves in water to form sodium ion and hydroxide ion. Therefore, it's an alkali. That's it. That's the only difference. Okay. Okay. You need to remember thymophthalin, the indicators. Okay. How many indicators are there? 3. Methyl orange, thymophthalin, and one more? Litmus. Okay. So you need to remember the color for methyl orange, in acid, in alkali, and in neutral for all 3. Okay, litmus not really lah. Litmus you've been learning since you were like year 7. Litmus, if it's alkali, blue, red litmus turns blue. If it's acid, blue litmus turns red. That one you know already. Okay, methyl orange in acid is red, but thymophthalin is colorless. This one you have to memorize. Okay, methyl orange in alkali is yellow, but in thymophthalin it's blue. Methyl orange in neutral is orange. That's why it's called methyl orange, but thymophthalin is also colorless. Okay, so these colors you have to remember. They're not going to give you an exam. Okay? So this one is an alkali. Okay, so in thymophthalin, this is blue and this is colorless because this is ethanoic acid. Do you know why is it ethanoic acid? Because we have studied that it is ethanoic acid. Okay. So who has the highest concentration of hydrogen ions? The one with the lowest pH. Okay, the second highest would be ethanoic acid. Ethanoic acid is still an acid. Okay. So who has the highest concentration? So nitric acid. Explanation, lowest pH. Do you understand? Do you understand the question? Okay. Okay, name an indicator. Okay, give me the answer for this. Read this question carefully. Universal indicator. Why can't I use litmus or methyl orange or thymophthalin? They only tell me one color, acid or alkali, neutral. They don't tell me the pH. Highest concentration of hydrogen ions means what's the pH? And you need universal indicator. Okay, because universal indicator has a whole spectrum of colors. Got it? Can remember now? Okay. Retinoic acid is a strong acid or a weak acid? Weak acid. Retinoic is a weak acid. All organic acids, all carboxylic acids are weak acids. Okay, I want you to try and do question 7, page 7. Just page 7. Just page 7. Okay? E, F, and G. Just complete this question. Do you remember how to count? I hope so. Okay, just try this question only. Okay, let's look at this. This you need to know is a weak acid. Okay, you need to know it's a weak acid. So in a weak acid, it is reversible. Here they wrote aqueous, so here also you need to write aqueous. That's why it's a 3-mark question. Okay? Now, this is a very common question. Neutralization between any acid and any alkali. If they ask you to write state symbols, you write like this. Because hydrogen ion is from acid, hydroxide is from alkali. You get water. But this question did not say state symbols, so no need. But if they write state symbols, it's usually a 3-mark question also, aqueous, aqueous, liquid. Got it? Okay. Okay, this is calculation question. Every time you see this unit, you always do MV over 1000 because this is the unit for molarity. Okay, we've done this a gazillion, gabillion, 100 times already. Okay, I hope by now you all know this. All right, so M for calcium hydroxide is 0.015. V is 20 over 1000. Okay, so 0.0003. You can write 10 power 94 as you can. Okay, the number of nitric acid. So remember, we always look at ratio. The ratio is this to this, 1 to 2. So you times 2. 0.0006. Did you get it correct? Yeah. And then finally, the volume of nitric acid is 25. So if you are not sure, use the formula. No one is rushing you to finish it during exam. You are looking 0.006 equals to M, which is what you're looking for, V, which is 25 over 1000. Okay? So M equals to 0.024 mole per decimeter cube. Did you all get it correct? Yeah? Okay, now I've talked to you about this before already. If from mole per decimeter cube, you want to change it to gram per decimeter cube. From here to here, you need to multiply molar mass. Molar mass of what? Molar mass of nitric acid. So nitric acid HNO3, 1 plus 14 plus 16 times 3, 78. 50. What is it? Is it 78? 63, sorry. So multiply 63. So 1.512 grams per decimeter cube. Okay. Okay? Did you get it correct? Can I? Okay. What is this, huh? What is this? This is a carboxylic acid. Carboxylic acid with one carbon is called methanoic acid. Okay? This is an alcohol. How many carbons do you see? 2. So 2 carbons is called ethanol. Right? Okay, what is the name of the ester? Anybody? Ethyl methanoid. You always use the alcohol name first and then methanoid. Okay? Okay? So they don't ask you, I'm just showing you. Okay, X is an ester, so this is ester. Name this type of the equation methanoic acid represented by HCOH. What kind of formula is this? No, no, no. Formula of this. So this kind of formula is called a structural formula. Empirical formula, simplest. So here, if you look at it carefully, it's H2, O2, and C. Can you simplify it anymore? No. Okay, you can write C first. C, H2O2. That's how we usually write lah. Usually in formulas, we write C and then H and then O. Okay, you can't simplify it because there's only one carbon. Okay? Displayed formula. Displayed formula is the one with the bonds. Okay, so the name that we already said, ethyl metanoate. Do you remember how to draw? Okay, what do? We take the acid first, HCOO, and then the alcohol, CH3, CH2. Okay, so please draw this here. HCOO, CH2, CH3. Okay, so this is the kind of questions that they ask you. Can you understand? Yeah. Okay. All right. This one is not a new chapter. This one is old, so you should know by now. What is named by a closed system? When it's closed, no reactant or product can enter or leave. Okay. Last time students wrote nothing can go in, nothing can go out. No, you cannot say that. You cannot say nothing can go in, nothing can go out. It's no reactant or product can enter or leave. Okay. Equilibrium says what? The rate of the forward and reverse reactions are equal and there is no more changes in the concentration of reactant and products. Okay. Okay. Are you able to do these kind of passive papers by yourself? You have to practice until you can do. Okay, you have to practice until you can do. If you have been listening so far in class, you should be able to do some. Okay. Can? You guys can? Can you try and finish this paper? Try and finish this paper. I'll just give you 5 minutes. If you cannot finish, it's okay. I'll teach you how to do. Do everything except for this one. This one I'm going to teach you today. How to do polymerization. Okay, I'm going to teach you today. Okay. Can you complete the paper? Then I'll teach you how to do. Jake, you okay? Do you remember how to do equilibrium? Okay, so they already show you here is exo. Alright? So if it's exo, that means this direction loves low temperature. Exo loves low temperature. Okay? So temperature is decrease, effect of the concentration increases. Got it correct? Okay, HCOH is decrease. You take this away, it will go the other way. So it will decrease. Concentration of both HCOH and CH3COH are decreased. It will still decrease. That means you remove both. You remove both, it will still go backwards. Okay, it will still decrease. And finally, if a catalyst is removed, there is no change. Remember, catalyst does not affect yield. Catalyst only affects which one? Rate, yeah. Catalyst only affects rate. Got it? Okay. Suggest why bute-1-ene. Okay, bute-1-ene is butene lah. What is the formula for butene and butane? Alkane, alkane is CnH2n plus 2. Alkene is CnH2n. Okay, so butane is the alkane with 4 carbons. So it's C4H. C4H10. And butene is C4H8. Okay, so why does bute-1-ene diffuse quicker? Okay, if you don't know this, we all sit down and cry. This is like chapter 1, year 10. Why does bute-1-ene diffuse quicker? Diffusion is based on what? Wait, huh? No, mass. Okay, mass, relative molecular mass. The one that is lighter will diffuse faster. So who has a lighter relative molecular mass? C4H8. Okay, lighter or smaller molecular mass. Alright, remember this is what you learned first chapter. The hydrogen chloride and the ammonia diffuse the white film. See which one forms where? It's this one. Okay. Identify the products formed when butane undergoes complete combustion. Complete combustion produces carbon dioxide and water. Okay, only incomplete can produce carbon monoxide. Okay. One molecule of butane reacts with one molecule of chlorine in the presence of UV light. I did the whole list with you before, right? Photochemical. Okay. If it needs ultraviolet light, it's called photochemical. Okay. What is the purpose of the UV light? To provide, close, very, very close. Very close. What energy is needed for a reaction to start?
Activation energy.
Thank you. Activation energy. Okay, to provide activation energy. The type of reaction, okay, you can go back and look at your reaction. There's like one whole list of reactions. Here's a flowchart. Okay, do you go home and sleep with your flowchart or not? Okay, you have to memorize this whole flowchart. Okay, so which reaction is the one that we're talking about here? Substitution. Okay. Replaces. One atom replaces. Replaces is substitution. How many different structural isomers can be formed during this reaction? Do you know what they're talking about? Butane is like this. Okay, very good. Why? I can have one chlorobutane and I can have two chlorobutane, right? Is there such thing as three chlorobutane? No, because you come from the other side. So there's two different isomers. Okay, bute-1-ene reacts with steam. Two possible products form. Okay, two possible products form. So meaning you add steam, right? You're adding water. Where do you add the water? You add it here, here. Change the single bond, right now. Or you can do HOH. If you do it like this, it's butane 2-ol. If you do it like this, it's butane 1-ol. The catalyst is phosphoric acid. If you can just remember the word acid enough already. Okay? There, our flow chart. This one there. 300 degrees Celsius, 60 atmosphere, and phosphoric acid. Get it? Okay. 2%. Oh, I drew for you already. Okay, so faster do butane 1-ol and butane 2-ol. Then I want to teach you polymerization. Then we do some more questions on acid base. Okay, when you draw this, right, remember it's O-H. Okay, can? All right. Boys, are you done? This one? Done with this one? Done, huh? Okay, I'm going to teach you this one now. Polymerization. Okay, what is polymerization? Polymerization, if you still have this, I'm sure you have this, right? I'm sure you have this, right? Because I gave it to you and I made you do it and I did it so long, and I'm sure you have it, right? Okay. So there are two kinds of polymerization. The first kind of polymerization that I'm going to teach you is called addition polymerization. Addition polymerization is how we make plastic. Okay, do you know what is plastic? Our plastic bottles. Okay, these kind of plastic bottles, anything, they are made through polymerization. Okay, now I want you to think of something. Uh, if I have solids, right? Okay, if I have a solid and I melt it, it becomes liquid. Correct or not? If I take the liquid and I freeze it, does it become back solid? Yes. Okay, so if I have solid like this and I melt it, it changes back like that, and I can become gas, right? Can I change it back? Can. Polymerization is different. Okay, I'm going to draw you one molecule. You must tell me what is this. Who is this? Ethene. Okay, if I draw ethene like this and I draw ethene like this, is it the same? Yes, yes. I'm just taking this hydrogen and I'm putting it down. I'm taking this hydrogen, I'm just pushing it down. It's exactly the same. So this is ethene, this is also ethene. Okay, can you see here there's a double bond? Double bond means the ethene, their hands are like that. That's double bond. Because the double bond, the hands are folded like this, can they open their hands and hold hands? Yes. They can do that when you compress them under high pressure with a catalyst. So what happens is I take ethene gas, and I compress them under high pressure and a catalyst. These ethene will join together, join, few thousand ethene until it becomes one big giant piece of plastic. Plastic got beginning and end or not? Don't have. Okay, can you change plastic back to gas? Cannot. That is what plastic is. Okay, so this is one ethene. Then you have another ethene. And you have another ethene. Okay, so what's going to happen is they are all going to open up their bonds in the middle, and they're going to hold hands with each other like this. And it will go on and on and on and on and on. So now it goes on for how many? It's not just three, it goes on for thousands. So now from ethene, it has changed to polyethene. Get it? Polyethene is the normal plastic that we have. And this is called addition polymerization. Okay? Addition polymerization. Okay. If ethene become polyethene, okay, can you see this one? The bond doesn't end, it goes on and on and on like that. Okay, so that's the difference. This one is not ethane, this one is not butane, it just goes on and on. This thing, like you draw like this with the single bond going out, this is called one repeating unit. So this is one repeating unit. So here I drew another repeating unit. So here got two repeating units. Get it? Can you see that? Okay. Now, if ethene becomes polyethene, which is plastic bag, propene will become polypropene. Do you understand? Okay. So what I want you to do now is, okay, we got no place here. We do it up above here lah. Okay, okay. You drew this one already? This one draw already? This one draw already? Yeah. Okay. Here up here got place. Okay, now what happens when propene becomes polypropene? Propene is C3H6. Can you try and draw polypropene, please? Now, if you did this, Your answer is wrong. Why? This is not polypropene. This is polyethylene. 1, 2, 1, 2, 1, 2. No, cannot. So what you need to do is, you must make it in such a way that the hands holding it is next to each other. Okay. This is what you need to do. Can you see this H? You move the H down. Can you see this CH3? You can move it up or move it down. So basically, it will look like this. H, H, CH3, H. Is this still propene? Is this still propene? Yes, no? Hello? Yes, this is still propene. But the sides are empty. This is what we want. The sides are empty. So, what is the alphabet in mathematics that means a lot? A certain number. N. Okay? So many of the propene joined together. This is polypropene. Do you understand? Can see it not? Okay, so this is one repeating unit. If I want to draw more repeating unit, I just draw again. HCH3. Do you understand? That's it? Okay, with your newfound knowledge, please do this one. Build one in. Okay. Yeah, can. They ask for 3 repeating units. This is how many repeating units? 2. This is 2 repeating units. 1, 2. The one below, they ask for 3 repeating units. Okay? Okay. Do this one. Done? Done with this? Okay, do this one. Do this one, then we're going to do another question of salts. Okay. Ready? Are you ready? All right. The type of polymerization I just told you is addition. Addition. I will teach you the next one another time, next week. Okay, that one's a little bit more complicated. So this is called addition polymerization. For those with addition polymerization, it must have carbon to carbon double bond. Okay? All right. So, did you all draw already? Poly build one in. So what you need to do is 1, 2, 3, 4. This is build one in, right? What is this thing? C2 H5. Get it? Okay. So H C2H5. Can you understand? 1 repeating unit, 2 repeating unit, 3 repeating unit. Okay? If you can do this last part, you have graduated from addition polymerization. Okay, I want you to draw. So this is how many repeating units? 3, 1, 2, 3 repeating. And the ends you must continue like that. You cannot end it. So this is a polymer, it's a plastic. This is how we make plastics. Okay. This is polybute-1-ene. I want you to draw polybute-2-ene. Polybute-2-ene. Okay. Do you understand what I want you to do? Okay, draw it now, quickly. There's empty space here. Bute-2-ene become polybute-2-ene. You must know how to use that itself. Okay, you must remember.
아니 뭘 사고쳤냐? 나 안 쳤어. 쳤어? 아니 왜 이거 아니 그냥 모기를 들을 수도 있어.
Let's pick it up. Let's continue on. This the sides also to you that it's line.
아니 여기 원래
No.
진짜 너무 짜서 그런 거
So how this is not the answer here?
근데 없어. 누구? 아저씨 진짜 없어. 일단 이외에 우리 없는
You have to do one of these now. You have to do this and you listen to that is. You see, if you take this.
근데 나는 그런 없잖아. 갈 데가 없어. 죄송한데
This is true medicine for my
저는 다른 수업을 X라고 구하게 되는 그 시간표 선생님 수업이 원장이
This is not one in. This is the isomer of one in. That's right. Don't trust the internet. This is true material for one in. Right or not? You have to draw something. Yes, but it's not. No, not like that. No. You must get bute-2-ene correct first. You must get bute-2-ene. Bute-2-ene means the double bond is in the second carbon. Look here, everyone look here. 1, 2, 3, 4. Bute-2-ene. Okay, we do this first. Don't do shortcut. When you don't know, don't do shortcut. Okay, Siwu, you must remember, your drawings, the end must go on. You cannot end like that. It has to go on. Okay? Can? Okay, look here. Okay. What is this? What is this? CH3. What is this? CH3. Got it? So it will be double bond CH3 or the other way around. This is how you draw it. Now you can do polybute-2-ene. Remember, your bond must be at the C. You can draw up or down, doesn't matter, but it has to be on 2 different carbons. Got it? And the end must continue like that. This is 3 repeating units. If they ask you to draw 1 repeating unit, you just draw 1 lah. But this question asks you to draw 3 repeating units. 1, 2, 3. So this is polybute-2-ene. Okay? Let's see. All right. Jake, okay?
Yeah.
Okay, guys, I'm giving you this paper now. Right. Which one I give you? This question is about salts that are soluble. This one. Okay, I'm giving you this one now. Okay, Jake, so open to this one. All right. See how good your memory is. Okay, please do question. Just try and do question 5 now. This question, this new one that I just gave you. It's salts and then organic chemistry. It's continued. Excuse me? Quiz, who is coming out salts? Please do it. Ha, 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 ha. All right. Do you remember how to make salts? What do? You take the sulfuric acid, you add until it's excess, then you filter. Do you remember? Okay. So, it's a 6 mark question, 5 mark question. This one is not paper 6, this is paper 4. Okay. How you would make a pure sample of zinc sulfate crystals. Practical details, how you would make sure all the dilutes are extracted. Chemical equation. So we do the chemical equation first. Zinc carbonate plus sulfuric acid, you get zinc sulfate plus carbon dioxide plus water. Okay, that already gives you 2 marks. Okay, so you add excess. You must say the word excess. Zinc carbonate to 20 centimeter cube of sulfuric acid in a beaker. Okay, filter to remove excess zinc carbonate. The filtrate is heated until saturated, then left to cool. Dry crystals between filter paper. Did you get it correct? Remember, you must add excess. Adding excess is how you get rid of all the acid. Can you understand? Did you get this correct? Yeah? Good. Okay? Ready? Yeah. Okay, some sulfates decompose when heated. When hydrated iron 2 sulfate is heated strongly, sulfur dioxide is given off. How do you test for sulfur dioxide? Acidified potassium manganate 7. What is the color? Purple too? Yes. Okay, now this one, right? Please remember, when you balance the equation, this one has to be 14. Okay? Because it's 2 times 7. So here 14. Okay. Some chlorides are hydrated. Hydrated means, okay, this one is called water of crystallization. Okay, water of crystallization means there are water molecules chemically bonded to the crystals. Okay, can? So, this is called hydrated. When there is no more water, it's called anhydrous. When it's hydrated, it is crystals. When it's anhydrous, it's powder. Okay? How can you sure all the water is given off? What must you do? You heat it and then how do you know all the water is gone? You heat already, then weigh, and then after that, heat again and weigh until the mass changes or doesn't change. Doesn't change until it remains constant. Okay, reheat and reweigh until a constant mass is reached. Okay, so this one is 4.88 and then this one is 4.16. Okay, number of moles of BaCl2 is 4.16 over 208. Correct? So 0.02. Remember, you must count this one, ah. Don't count around, you count 4.88. Is it? Okay. Mass of water is you minus. You have to take 4.88 minus 4.16. Okay. Moles of water 0.72 over 18. 0.04. So what's the ratio? 1 to 2. So X is 2. Do you understand? Yeah? Okay, good. Okay, this question is about organic chemistry. You can use the chart that I gave you last week to do this question. Okay, this one is empirical formula. I'm pretty sure you can do. This question is about functional group and ester. Okay, it's everything I taught you last week. Please do it now. Quickly, quickly. Please do it now. Please. This one. Empirical formula first, and then continue. Okay, so let's look at this. Okay, how do you calculate empirical formula? You divide the molar mass. Eh, okay, you must show your working, guys. Show your working. Okay. So remember, it's mass over molar mass first. Okay. Aiya. Okay, what do you do now? You divide the smallest number. Who's the smallest number? 1.16. So C5H10O. Did you get it correct? Hey, empirical formula also forgot how to do. What did you do instead? Do I want to know? Okay. Compound S has the empirical formula. Okay. Empirical formula and relative molecular mass. How you calculate is you find N. You take 60 over this total. C2, CH2, O is how much? 30. So it's C2H4O2. Get it? Did you get this correct? Okay. Compound T and V have the same molecular formula. Compound T is an ester. Compound V is a functional group, has COH. So obviously, compound V is an acid. Okay, an acid with 3 carbons is called what? Propanoic acid. Okay? Same molecular formula but different is called structural isomers. Homologous series of V. The question is asking you homologous series, not the name. So you have to say carboxylic acid. Get it? Do you understand? Boys, did you get it correct? Jake, got it correct?
Yeah.
Okay. Okay. Draw a structure of compound T. Compound T is an ester. You can either draw ethyl because they don't say which one it is. So you can either have it's either methyl ethanoate or ethyl methanoate. Do they say which one? No, so you can draw whichever. Okay. As long as you have 3 carbons. So if you draw this, it is ethyl methanoate. If you drew it the other way around, what is the other way around? The other way around is like this. If you drew this, what's the answer? If you drew this, what is it called? Methyl ethanoate. Okay, is there a difference? Yes. Which one is correct? Both are correct because the question did not say specify. So these are structural isomers of each other as well. Okay. V is propanoic acid. Ethanol can be produced from a long chain such as decane. What is this called? Long chain this is called cracking. Then this one to here is called catalytic addition of steam. Okay. We did this last week and many weeks ago. You guys have to memorize your flowchart. If not, you cannot do anything. Okay. So the type of reaction is cracking. Decane is C10H22. If it becomes ethene, ethene is C2H4. How many left? C8H. 18. Okay. catalytic addition of steam. C2H4 plus H2O become C2H5OH. Okay? The only way you can do this is you have to memorize all the general formulas. Okay? Alright, please go home and study. Okay, I'll see you Saturday. Bye, Jake. See you.
Okay, bye.
Bye.